Every night, she rises, silent and luminous, casting her silver glow across our world. The moon has been humanity's most faithful companion for countless millennia. Ancient shepherds guided their flocks by her light. Poets penned verses to her beauty. Lovers whispered promises beneath her watchful gaze. But here's what's remarkable. In all those thousands of years, across every civilization that has ever looked up at the night sky, we have only ever seen one face of our celestial neighbor. The same craters, the same shadows, the same mysterious patterns that our ancestors called the man in the moon or the jade rabbit. Think about that for a moment. Generation after generation, from the first humans who walked upright to the astronomers of today, we've all gazed upon the exact same lunar landscape. The moon has shown us her face, but never turned to reveal what lies on her other side. This isn't mere coincidence. It's celestial choreography on a cosmic scale. Our moon performs an ancient dance, rotating at precisely the same rate that she orbits Earth. Like a shy dancer eternally facing her partner, she keeps one hemisphere perpetually hidden from our view. For most of human history, that hidden hemisphere remained the ultimate mystery. What landscapes lay concealed in that eternal darkness? What secrets had been gathering dust in those unseen craters for billions of years? The far side of the moon, forever shrouded, forever unknown, beckoned to us like a forbidden realm just beyond our reach. Tonight, we're going to journey into that darkness together, to explore the alien world that exists just 240,000 miles away, yet remained hidden from human eyes until the space age dawned. What we've discovered there challenges everything we thought we knew about our nearest neighbor, and opens doorways to possibilities that stretch far beyond our imagination. To understand the mystery of the moon's hidden face, we must first unravel one of the most elegant puzzles in our solar system. Picture two dancers, locked in an eternal waltz. One spins slowly as she circles her partner, but she spins at exactly the right speed so that she always faces him. This is the moon's dance with Earth, a phenomenon scientists call tidal locking. Billions of years ago, when the moon was young and wild, she spun freely through space. But Earth's gravitational embrace gradually slowed her rotation, like a gentle hand steadying a spinning top. Over eons, the moon's spin synchronized perfectly with her orbit around Earth. The result? One hemisphere became permanently Earth-facing, while the other turned away into cosmic solitude. This is where we must dispel one of the most persistent myths about our lunar companion. Popular culture often speaks of the dark side of the moon, immortalized in music and movies as a place of perpetual night. But this is a beautiful misconception. The far side of the moon isn't dark at all. It receives just as much sunlight as the near side. When we see a new moon in our sky, the far side is actually bathed in brilliant sunlight, and the far side isn't dark. It's simply hidden. Hidden from Earth's direct observation, hidden from our radio signals, hidden from the casual glance of every human who has ever lived. It's a hemisphere that exists in perfect isolation, as foreign to us as the surface of a distant planet. For centuries, this cosmic curtain tantalized scientists and dreamers alike. What lay beyond that veil? Early telescopes revealed the near side's majestic craters and vast dark plains. The lunar seas that aren't seas at all, but ancient lava flows frozen in time. But that other half of the moon? It remained as mysterious as it had been to our cave-dwelling ancestors. The far side became the ultimate frontier, closer than Mars, yet more inaccessible than the deepest ocean trench. It waited there, patient and enigmatic, holding secrets that would challenge our understanding of both the moon and the violent early history of our solar system. October 7th, 1959. While most of the world slept, a small Soviet spacecraft named Luna 3 accomplished something that no human eye had ever witnessed. Sailing through the cosmic void, this mechanical explorer swung around the moon's far side and, for the first time in history, photographed the hidden hemisphere. The images that Luna 3 transmitted back to Earth were grainy and imperfect, but they might as well have been photographs of an alien world. Because in many ways, that's exactly what they were. Where scientists expected to see familiar lunar seas, those dark, smooth plains that dominate the Earth-facing side, they found instead a landscape of almost unimaginable violence. Crater upon crater stretched to every horizon, overlapping and intersecting in a chaotic tapestry of ancient impacts. The far side appeared rougher, more battered, more alien than anyone had dared imagine. The contrast was startling. The near side of the moon, with its relatively smooth dark maria, looked almost gentle by comparison. But this hidden hemisphere told a different story entirely, a tale written in impact. Craters and highland terrain that spoke of cosmic bombardments. Spanning billions of years, scientists stared at these first images with a mixture of wonder and bewilderment. Why was the far side so dramatically different? Why did it lack the vast lava plains that characterized the familiar face of the moon? It was as if they had discovered that their quiet neighbor had been hiding a violent, scarred twin as later missions, both American and Soviet, sent back clearer images. The mystery only deepened. The far side wasn't just different. It was fundamentally alien in character. Here was terrain that had remained virtually unchanged since the solar system's violent youth. A museum of cosmic catastrophes preserved in the airless cold of space. Among the most striking features was the South Pole Aitken Basin, a scar so massive it could swallow entire nations. This crater, nearly 1,600 miles across, represented one of the largest impact events in the inner solar system's recorded history. And it was completely invisible from Earth. Hidden away on this alien hemisphere like a cosmic secret, the far side had revealed itself to be not just the moon's other face, but perhaps the key to understanding the violent birth pangs of our entire cosmic neighborhood. Now, let us journey to one of the most haunting landscapes in our solar system, the lunar poles, where some craters haven't seen a single ray of sunlight in over 2 billion years. Picture, if you can, the rim of Shackleton crater at the moon's south pole. Here, the sun hangs forever low on the horizon, casting impossibly long shadows that stretch like dark fingers across the lunar landscape. The crater's interior lies in eternal night, a bowl of darkness so complete that it makes Earth's deepest caves seem bright by comparison. These permanently shadowed regions exist because of the moon's unique relationship with the sun. Unlike Earth, with its pronounced seasonal tilt, the moon's axis tilts only slightly. This means that the floors of polar craters, these deep bowls carved by ancient impacts, can remain in shadow for geological ages. Step into one of these shadow zones, and you enter a realm where time seems frozen. The temperature plummets to minus 375 degrees Fahrenheit, colder than the surface of Pluto, colder than liquid nitrogen. Here, in this cosmic deep freeze, molecules move so slowly they might as well be trapped in amber. The silence in these places would be absolute. No atmosphere exists to carry sound, no wind to disturb the ancient dust. If you could somehow stand on the floor of Shackleton crater, you would find yourself in a cathedral of cosmic solitude, surrounded by walls that tower miles above you, their peaks occasionally catching the ghostly light of Earth hanging in the black sky. But these aren't merely empty holes in the ground. Each crater tells a story of cosmic violence, of asteroids and comets that struck the moon with the force of billions of nuclear weapons. The impacts that carved these craters occurred during the solar system's youth, when space was thick with debris and collisions shaped the faces of worlds. These permanently shadowed regions represent some of the most extreme environments in our solar system. Yet they've become among the most scientifically valuable. Because in that eternal cold, in that perfect preservation, these craters have become time capsules, repositories of materials that have remained unchanged since the dawn of the solar system. Deep within those eternally dark craters lies one of the most extraordinary discoveries of the space age: water. Not the liquid water of Earth's oceans, but something far more precious in the context of space exploration: billions of tons of water ice, preserved in the lunar permafrost like cosmic treasure. The discovery came gradually, through decades of patient detective work. First, neutron detectors on orbiting spacecraft detected unusual readings from the polar regions, hints that hydrogen atoms were concentrated in those permanently shadowed areas. Then came more sophisticated missions, each adding pieces to the puzzle. In 2009, NASA's Lacrosse mission provided dramatic confirmation. They deliberately crashed a spent rocket stage into Cabeus crater, creating a plume of debris that rose above the crater's rim into sunlight. where instruments could analyze it. What they found was remarkable. Not just water ice, but a cocktail of other frozen materials: carbon monoxide, hydrogen sulfide, ammonia, and even trace amounts of mercury and silver. But how did water come to exist in these airless, frozen pits? The answer takes us back to the violent early days of our solar system. Comets, those dirty snowballs from the outer reaches of space, regularly bombarded the moon during the period scientists call the Late Heavy Bombardment. When these icy visitors struck the lunar surface, most of their water vaporized and escaped to space. But some molecules found their way into these polar cold traps, where they've remained frozen for billions of years. Imagine these ice deposits as libraries written in frozen molecules. Each layer tells the story of ancient cometary impacts, preserving samples of water that might have originated in the distant Kuiper Belt or even the Oort cloud at the very edge of our solar system. This ice carries within it the chemical signature of the early solar system, a time when planets were forming and life on Earth was just beginning to stir in primordial seas. For future lunar explorers, this water represents something even more valuable than scientific knowledge. It represents survival itself. Water can be split into hydrogen and oxygen, providing both breathable air and rocket fuel. These frozen deposits could serve as cosmic gas stations, enabling journeys deeper into the solar system than ever before imagined. The far side of the moon serves as our solar system's memory bank, preserving evidence of cosmic events that occurred when Earth was still a hellish, molten world. Every crater tells a story, and collectively, they chronicle the most violent chapter in our cosmic neighborhood's history. 4 billion years ago, during an epoch scientists call the Late Heavy Bombardment, the inner solar system was a shooting gallery of asteroids and comets. These wandering chunks of rock and ice, stirred up by the gravitational influence of migrating giant planets, rained down upon the moon, Earth, and other inner worlds with devastating frequency. Earth's active geology has long since erased most evidence of this ancient catastrophe. Our planet's surface recycles itself through plate tectonics, weathering, and erosion, constantly rewriting the geological record. But the moon, airless, geologically quiet, and patient, has preserved this violent history in exquisite detail. Each impact brought with it more than just destruction. These cosmic missiles delivered exotic materials forged in the hearts of distant stars or in the cold depths of the outer solar system. Rare earth elements, platinum group metals, and isotopes that barely exist on Earth lie scattered across the lunar surface, concentrated in impact sites and preserved in the vacuum of space. Some of the most intriguing materials may not even be from our solar system. Scientists theorize that interstellar dust grains, microscopic visitors from distant star systems, have been collecting on the moon for billions of years. The far side, shielded from the solar wind's erosive effects by the moon's bulk, may preserve these alien materials better than anywhere else in the inner solar system. Consider the South Pole Aitken Basin, that massive scar we glimpsed in early spacecraft images. The asteroid that carved this crater was so large it punched completely through the moon's crust, excavating material from deep within the lunar interior. The impact ejecta from this event spread across thousands of miles, creating a natural laboratory where materials from the moon's deep interior lie exposed on the surface. Recent missions have detected unusual concentrations of metals like iron and titanium in this basin, evidence that the impact reached all the way to the moon's mantle. This cosmic excavation has given us a window into the moon's internal structure that would have been impossible to achieve any other way. Turn your radio telescope toward the far side of the moon, and you discover something remarkable: silence. Not the absence of cosmic phenomena, but the absence of human interference. Here, shielded behind 2,160 miles of solid rock, lies the quietest place in the inner solar system. Every moment of every day, Earth broadcasts a cacophony of radio signals into space. Television transmissions, cell phone networks, Wi-Fi signals, radar installations. Our planet buzzes with electromagnetic chatter that drowns out the faint whispers from the cosmos. For radio astronomers trying to detect subtle signals from distant galaxies or the cosmic microwave background radiation left over from the Big Bang, Earth's radio noise is like trying to hear a whisper in a hurricane, but the moon's far side sits in a zone of perfect radio silence, naturally shielded from Earth's electronic babble. Here, radio telescopes could operate with unprecedented sensitivity, detecting signals so faint they would be completely lost in Earth's electromagnetic noise. Imagine what we might hear from that cosmic quiet. The far side could serve as our listening post for signals from the universe's infancy, the afterglow of the Big Bang itself, stretched and redshifted by billions of years of cosmic expansion. We might detect the radio signatures of the first stars that ever formed, or the electromagnetic echoes of black hole collisions from galaxies billions of light years away. Some scientists even speculate about more exotic possibilities. In that perfect silence, we might finally answer one of humanity's most profound questions. Are we alone? The search for extraterrestrial intelligence could benefit enormously from the far side's radio quiet, listening for artificial signals that would be impossible to detect from Earth, but the silence itself holds an eerie quality. Standing on the far side of the moon, an astronaut would be more isolated from human contact than anyone has ever been. No radio signals from Earth could reach them directly. No cell phone could connect them to home. They would exist in a bubble of absolute communication isolation, accompanied only by the distant stars and the alien landscapes stretching to every horizon. This isolation isn't just physical, it's philosophical. The far side represents the ultimate frontier of human exploration, a place where we must rely entirely on ourselves, cut off from the reassuring chatter of civilization. Long before spacecraft revealed the moon's hidden face, human imagination had already populated that mysterious realm with wonders and terrors. The dark side of the moon became more than just an astronomical curiosity. It evolved into a powerful metaphor for the unknown, the hidden, and the forbidden. Pink Floyd immortalized the concept in their legendary album, using the far side as a symbol for mental isolation and the unexplored territories of human consciousness. The hidden moon became a canvas for our deepest fears and most profound longings, a place where anything might be possible because no human eye had ever confirmed what lay there. Ancient cultures, unaware of tidal locking, nevertheless sensed something profound about the moon's fixed gaze. Chinese mythology spoke of Chang'e, the moon goddess, eternally separated from her lover and dwelling in a lunar palace. But what of the moon's other side? Some legends hinted at a mirror realm, a shadow world where the rules of our reality might not apply. Science fiction writers embraced the far side as the perfect setting for alien bases, secret installations, and cosmic mysteries. H.G. Wells imagined Selenites dwelling in caverns beneath the lunar surface. Later authors populated the hidden hemisphere with everything from Nazi moon bases to alien observation posts, each story feeding off the tantalizing fact that this nearby world remained completely unknown. The mystery of the far side tapped into something fundamental about human nature, our compulsion to explore, to know, to push beyond the boundaries of the familiar. Every culture has tales of heroes who journey into unknown lands, facing dangers and discovering wonders. The moon's far side represented the ultimate expression of this archetypal journey, a quest into literal terra incognita that lay visible in our very sky. Even today, when we've mapped every crater and measured every mountain on the far side, something of that mythic quality persists. The hidden hemisphere still represents the unknown, the unexplored, the next frontier waiting for human footsteps. It reminds us that mystery doesn't vanish with knowledge, it simply transforms, revealing new questions and deeper wonders that call to the explorer in every human heart. The age of lunar exploration is dawning anew. And this time, the far side calls to us with irresistible urgency. NASA's Artemis program aims to establish a permanent human presence at the lunar South Pole, while China's ambitious Chang'e missions are already scouting locations for future bases. The hidden hemisphere, so long the realm of robotic explorers, may soon echo with human voices. Picture the first astronauts to set foot in those permanently shadowed craters. Equipped with advanced lighting systems, they'll illuminate landscapes that have known only darkness for billions of years. Their footsteps will mark the first time in cosmic history that any living being has walked through those ancient impact sites. carrying the spark of consciousness into realms where only inanimate matter has existed. These future lunar explorers won't be mere visitors. They'll be pioneers establishing humanity's first permanent foothold on another world. The water ice locked in those polar craters will fuel their rockets and fill their lungs with oxygen. Solar arrays positioned on crater rims, where sunlight never sets, will power their habitats. The far side's radio silence will enable scientific observations impossible anywhere else in the inner solar system. But perhaps most exciting is the far side's potential as a launching pad for deeper space exploration. With gravity only 1/6 that of Earth and no atmospheric drag to overcome, rockets launched from the moon can reach the outer planets with a fraction of the energy required for Earth-based missions. The hidden hemisphere could become our species' springboard to Mars, Europa, and worlds we haven't even imagined yet. Advanced telescopes built on the far side, shielded from Earth's radio interference and protected from meteor impacts by the moon's bulk, could peer deeper into space and further back in time than any instrument we've ever constructed. From there, we might observe the formation of the first galaxies, track potentially hazardous asteroids, and search for signs of life around distant stars. The vision extends beyond mere exploration. The far side could host manufacturing facilities taking advantage of the moon's vacuum and low gravity to create materials impossible to produce on Earth. Helium-3, deposited by the solar wind and preserved in lunar soil, could fuel fusion reactors that provide clean energy for both lunar colonies and Earth. We stand on the threshold of this new age of exploration. The far side of the moon transforms from mysterious destination to launching point, not just for rockets, but for humanity's expansion into the cosmos. And so we return to our original question, though perhaps now we understand its true depth. What lies in the moon's eternal darkness? The answer, we've discovered, is not just a catalog of craters and ice deposits, not merely a collection of scientific data and mineral resources. What lies in that darkness is nothing less than the story of our solar system's violent birth, preserved in airless perfection for 4 billion years. It's water from ancient comets, carrying the chemical signatures of stellar nurseries light years away. Its rare elements forged in the nuclear furnaces of dying stars, delivered to our cosmic neighborhood by wandering asteroids. But more than that, what lies in the eternal darkness is potential, the potential to transform humanity from a single planet species into cosmic citizens. The far side offers us not just scientific knowledge, but the practical resources to reach for the stars. Its silence promises answers to our deepest questions about the universe and our place within it. Perhaps most importantly, what lies in that darkness is a mirror that reflects our own nature back at us. The far side reminds us that we are explorers by birthright, descended from ancestors who crossed oceans and continents driven by the same curiosity that now calls us to other worlds. Every generation faces its own far side, its own unknown frontier that beckons with equal measures of promise and peril. The moon's hidden face has taught us that mystery doesn't diminish with knowledge, it deepens. Each answer we've found there has revealed 10 new questions. Each image transmitted back by our robotic explorers has shown us wonders we never imagined and posed puzzles we're only beginning to solve. As you drift towards sleep tonight, perhaps you'll glance up at the moon hanging in your window. Remember that what you see is only half the story. Behind that familiar face lies an alien world of eternal shadows and ancient ice, of cosmic violence and pristine preservation. It waits there, patient and mysterious, holding secrets that could reshape our understanding of the universe and our species' destiny among the stars. The far side of the moon isn't dark, it's simply unknown. And the unknown, as every explorer throughout history has discovered, is where the greatest adventures begin. In those eternal shadows lie not just the remnants of our cosmic past, but the keys to our interplanetary future. What truly lies in the moon's eternal darkness? The next chapter of human civilization itself, waiting for us to have the courage to step into those shadows and discover what wonders await beyond the light.